it's exactly like what we just thought. It's, I mean,
To the now.
I feel like you need to tell them if you like confused.
Yeah, no, this is the JavaScript stuff. The only code I wrote.
He accepted it, but he like wants me to change a lot of stuff. I'm just doing some tic-tac-toe or whatever. But he like told me that it's fully observable, and I said that it was partially observable, and so he wants to
Yeah.
I like really don't want to use that.
Yeah, that's the thing about it. It's got some
Because I
more
want to be able to know if it's working. I don't feel confident just like
All right,
assume that it's okay.
let's go get started. Welcome to Lecture 18, CSC 5323, 7323, Mobile Sensing, Learning, and Control. And just like we start out every class, let's just jump right in. Course logistics. A4 grades are not up yet. I said I was going to get to them over the weekend. I did not. Sorry. A5 is still due Friday. Sensors, is everybody still good with getting sensors? We had talked about getting sensors last time, and then Wednesdays people were like, oh, I've got all these ideas for how I'm going to grab some sensors, because you basically need two, and I'm saying that a potentiometer is a sensor. You guys good? Not good? Who's having trouble? Who's not far enough along yet to know if they're in trouble? All right, excellent. Moving on. Okay. All right. So my sensors and stuff, they're still sitting. All of the things that I had last Wednesday during lab, I threw in the cabinet right after lab. You've got them right over there. So they're essentially be in the cabinet. When you're not using them, just throw them in the cabinet so that people can have access to them. So you're happy to use them. Moving on. So agenda for today, I'm going to finish off our kind of crash course introductory to Python. And I'm going to briefly go over classes. We kind of got into it last time, but it was really, really rushed. I'm going to go over the with statement. I'm going to talk about debugging. And we'll go into some very quick Python demos. We're not going to get out of Python today. The rest of the lecture, we're going to talk about something called Tornado and then PyMongo. Which is for interfacing with MongoDB. At least I'm hoping we'll get to PyMongo today. All right, so the classes structure that's set up in Python. First of all, what was Python? Let's just get back into it's a scripting language. Yeah, let's just get back into the mode. It's a scripting language. It's an interpreter. Goes line by line. We write some for loops. There was the is and the and the or keywords, and we were all really happy with the way that Python was structured, right? And it's a strongly typed language. No, it is not. All right, good. Someone's listening.
It sounds like a question. It sounds like a statement.
It did sound like a statement. I was hoping someone would be like, huh? And they were. Okay, so, all right, so it's very weakly typed. It's dynamic typing, right? Okay. Good. So when you're setting up a class structure, you can still set up inheritance in Python. And we went over this briefly last time. If I wanted to set up a class called bodyPart, I could say this is a class and it's called bodyPart, and it inherits from another class, which is the generic Python object, right? So it inherits from object. So you can see object right there. That's the class that it inherits from. You can have multiple classes there, right? And it will inherit from multiple classes, okay? When both of those classes implement the same function, then essentially it will go through the first object that it inherits from, and if it finds a match for the class, it will call that superclass. Okay? That's how the way that multiple inheritance works in Python. Very, very similar to other languages. Okay? Every class, you'll have this underscore, underscore, init, underscore, underscore. And essentially, when you wanted to initialize this class, self is the first variable that comes in, but then everything after that are variables that you can use to initialize your class. So for the body part class, I'm expecting the user to pass in the variable name, and I'm going to say self.name is equal to name. And that way, anytime this class gets used in the future or I call additional functions on this class, I will have access to the property self.name. Okay? So now if I wanted to set up this thing, a class called heart, which is of type body part, and it inherits from body part, does this also inherit from object? Yes. Good. Easy question. All right. I got a quick nod. I'm moving on. So with this heart function, essentially, I'm going to define the initializer, and I'm going to say the first thing that gets passed in is self, even though that's not an explicit argument that you pass in. But with this, there are two other properties that get passed in. One of them is rate, and one of them is units, right? And so this would say rate is equal to 60. The units is in minutes, right? So that's essentially 60 beats per minute that I'm setting this heart to, okay? I could also set this up in seconds if I wanted to, right? It's up to the user to pass that in. So now I can set the self.rate and self.units properties, and those don't have to be the same names as the properties that you're sending into the initializer. Everybody okay with that? Okay. And then essentially I can also call the superclass initializer by just calling super, and then I'm going to give, this is of type heart, self, and then the initializer is this. So what does this line of code do? Somebody tell me. It calls the superclass init, and it sets name equal to heart, right? Right. So this, it's passed in as the first argument, is name. Okay. So I can also define a class function called print rate, right? And so this would take the argument self right here, and it says print, and it goes name, and then a string self.name has self.rate beats per self.unit. Okay. So if I were to call this right here, right, where I say my heart is equal to heart 1 second, that gives me an instance of the class heart where rate is set to 1 and units is set to second. Okay? And now when I call myHeart.printRate, notice that this took a self as an argument. I'm not passing in self here. Okay? Right? That is essentially passed in for you by having an instance of the class. Okay? Happiness? Okay. So if I were to do this, I would get name heart has 1 beat per second in the print rate function. So that's classes. Okay. The with syntax. We had to talk about classes before we talked about the with statement. Essentially, what this does is it defines these classes that are called the enter and an exit protocol for your class, right? And so the best way to actually explain the with statement and why it exists in Python is just to go through an example. So if you wanted to open a file, right, and you wanted to read from it or write to it, how would you do that in what's the general structure? Any programming language. You want to open a file.
You create a file pointer.
Yeah. Yeah. You get a file pointer, right, essentially, right? Something that points to where that file exists at, right? And you try to open it, right? Then what do you do? Check to see if it's open. And if it's not, handle an error, whatever you do when if that file didn't exist, right? Or you couldn't open that file because it was locked, or whatever the scenario is, okay? So essentially, if you were going to do this in Python, it would be file equals open, and then I would basically say, okay, some file.txt, okay? And now I'm going to say try data equals file.read, okay? And then finally file.close. What this does right here is this finally command, right? I could have wrote catch here, and I could have caught any errors that happened. This finally command will always happen, right? So if that file didn't exist, it would call file.close to make sure that that's not something that is active, right? And after I've done reading it, I could also call file.close. This is considered too verbose for Python, okay? That is where the with statement comes from. So the with statement defines an enter and an exit protocol, which would be essentially doing this try and finally command, So I can also do this exact same line of text with this command right here. It says with open some file.txt as file, data equals file.read. Okay, what that does is essentially it tries to do this statement right here inside of a try-catch block. If something happens, it will not execute this line of code that's underneath the with statement. Okay, it'll just exit normally. Okay, you can define your own classes, and as long as that class has an enter protocol and an exit protocol, so underscore underscore enter and underscore underscore exit, as long as those are two functions defined in your class, you can use with your class. Okay, and it will automatically use your enter and exit protocols. Okay?
So the exit protocol would have the close statement here?
Yeah, exactly. So what it does is it looks at that, it says, okay, this is an open statement, right? So it's essentially going to try to get a file object. And it's going to say if that didn't open, close it. Yeah, that's in their exit protocol for this. Okay? Debugging. All right, before we go into examples, I want to show you how to do some debugging in Python, because even people that have programmed in Python for a very, very long time, what I see is people using print statements a lot, right? And that's okay for very, very quick running Python code. However, if you ever get into something where you're staring at your code and you don't know where to, print out variables, you're not sure where an exception is occurring, that's not going to cut it, right? I love to set breakpoints and see what's going on in the code and trying to look at things. So you can do the same thing in Python, and you can do it from the command console. And the way that you're going to use it is we're going to use the Python debugger, something called PDB. Okay? Yeah, seriously, if you haven't used this and you used Python before and you have no idea what PDB is, I just changed your life. Okay? You are going to change the way that you debug Python code from now on using PDB. Essentially what you'll do is you'll use the statement import PDB, and now you have access to do these things called like pdb.setTrace. And that's essentially setting a breakpoint inside of the code. Whenever it hits that pdb.setTrace, it immediately will go to your console, right? And you can do it's an interpreter now, so you can change variables, values, you can print statements, right? You can do any Python piece of code you can do inside of that, and then you can say, okay, continue or step through, step into, all of that stuff.
So you use this for compiled Python or for like Python scripts? Like you put that in a Python script?
You put this in a Python script to run. If you have compiled Python, that's okay. That's fine. You can still run it from here. And it will still set a debug trace because compiled Python is compiled. So essentially what it'll do is when you call this pdb.setTrace, it will now provide, it'll give control back to you on the command line. So you could say something like S, enter, and that will step through your code. Continue. There's the next statement, where, list, return, and jump. Okay? All of these things you can look up in the PDB. Just Google PDB in Python, and you will get a lot more commands that you can do right here. But essentially, you can also do things like print. You can do P and PP and that kind of stuff. And essentially, you're going to use the print statement most of the time when you actually want to go in or manipulate some of the variables that are there. You don't have to use this from the command line. You can set numbered breakpoints and say, I only want to break on breakpoint number 3, right? And you can have essentially numbered breakpoints in your Python code. So that if you were to call Python -m pdb your function.py, you can also give it certain breakpoints that you want it to break on. Or you can have it break on conditionals, like when this is true. Okay? So I will use this to make this a little more concrete. Okay, so let's do a demo. Let's plot some data from a file. Okay, and maybe we'll actually plot some data from the audio card too with Python. So essentially, I've got a couple of things here out on the desktop. So the first thing I'm going to show you is this adc_data.txt. Bam. This is what it looks like. This is the output of something called a Blue Sentry Bluetooth module. I had a company that was using it, and they sent this file to me, and they were like, I have no idea how to interpret all of this text. I think there's something wrong. And I was like, okay. And essentially what happens here is for each line of this, what they did was they had this Blue Sentry thing that was connected up to a COM port on their computer, and they were just having it dump to file, right? And essentially, each one of these 2 bytes, these 16-bit numbers that come back, these are all hex numbers, right? Saved as ASCII text for whatever reason. And each of these represents an ADC value from this little Blue Sentry module, right? So it's this little Bluetooth module. It's streaming over a COM port, and it spits out different ADCs that it has connected on this module. Okay, so I want to read in each of these and plot them. Right, so I want to plot this entire column, etc., etc. This right here is just telling me, this first column is just telling me what order the bytes come in. Okay? Is this okay? You guys good? All right, so I'm going to read this file. So let's do this. Right, this just opened in. Yeah, that's fine. We can run it from here. Okay, so Xcode. All right, so what I'm going to do here is I'm going to import matplotlib. Okay, this is something I installed by saying sudo port install matplotlib, and it installed it for me. This is essentially, has anybody ever used MATLAB before? Yeah? Did you like the plotting in MATLAB? Yeah. Well, you didn't? Well, then you're not going to like this. This is very, very similar to plotting in MATLAB, right? You just, once I have some data, what I can do is I can say this. You see how it's called this import matplotlib.pyplot as PLT? So this as PLT, I can say plt.plot ADC1, ADC2, and these are just essentially arrays of data. Okay? And then I'll say plot.show at the very end. But essentially what I'm going to do here is, we don't need to pay attention to this function right here. I'm going to set up these 4 variables. I'm going to set them to equal be empty. And then I'm going to go say with open adcdata.text as f. Right? What does that do? Yeah, it opens the file, and the pointer is f. Okay? So now I'm going to say for line in f, for each line in that file. Right? Maybe I should have called it file. Maybe I should have called it file. 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 For line and file. Save. I'm going to say adc1.append, convert that ADC value, right? Based on the ASCII text that's there. Okay, so I'm going to take that ASCII text and convert it over to a float. That's essentially what that does. And if you want to see that code, it's right up here. Voila. Okay, there's also some other stuff in here because there's a max int, a voltage, a slope, and an offset that they gave me. Essentially, they were converting this over to another value. It was a pressure value based off of the voltage. So I converted it to a voltage. From voltage, I converted it over to a pressure value. It was a pressure sensor they had attached. Okay. So then I'm going to plot these. So let's run this. I already have a terminal open. Let's new window. Okay, so change the font size. I think we used 18 last time. That's good. Okay, so what I'm going to do is let's change directory to, I think I'm on the desktop. Yes, I am. bluesentry.py is the font we were looking at. So I'm going to say, okay, Python 2.7. And then I'm going to say bluesentry.py will execute this command. It's going to go through, it's reading the file, and voila, I have now printed the values that were inside of there. Okay? Wow. Excellent. Now I can close that and it'll return. So essentially, I can't remember how many things there were inside this file, but if I wanted to use PDB, I can say import PDB right there. And then what I'll do is I'll say this pdb.setTrace right here, right before I open up the file. Okay? I'll save this. And now I'm going to call this. And bam, I just hit that breakpoint. So I can say step, step, and it's telling me. So I'm 4-line in file. Now I'm at adc1.append. Right? I'm at adc2. Maybe I wanted to see what's inside print adc1. It's empty right now. Okay, so I could say next, 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 next. Okay, now I'm at ADC2. So now if I want to do a print command, print ADC1, it's got a value in it. Okay, so I can go through and I have access to everything. So I'm just going to continue, let this go through the whole thing. Voila. Okay, so that is how you set breakpoints in Python, right? I don't know how many people I've met that don't know that. It is there. You can set a breakpoint in Python. You can also do it with their IDE, and I like using the command lines, but you can do it if you want. Okay. All right. So that was one example. That was bluesentry.py. Let's look at audio samples. Why don't we open this thing up? Did I really just close terminal? Oh well. So here I'm actually importing a lot of different things. I've got matplotlib. I've got this thing called numpy, math, struct, and pyaudio. Okay. These were all things that I installed using sudo port install. Okay? Essentially what this is going to do is, I'm not going to go through all of this in depth here because I just want this to be an example. But essentially, I can get a handle to the audio card using this function of where pyaudio is. And then I can set up my stream. I can set up, okay, here's how many audio samples I want from the audio card. Here's what I want the frame rate to be. Here's what I want my sampling rate to be. All the stuff that you normally set up, what we did say in iOS, right, with Lab 2. So I'm going to take it. I'm going to get a bunch of samples from my audio card, and then I'm going to plot them. Okay? Actually, I'm going to do more than that. I'm going to take the FFT of them and plot them. Okay? Using NumPy. NumPy has this FFT built in. Okay? So if you've ever used MATLAB, NumPy is essentially the equivalent of MATLAB for Python, except it's open source, okay, and free. Yeah.
So with the breakpoint, I don't think we'll see an example yet, but do you actually put that in code or do that from the command?
I did that in the script. I called pdb.setTrace, and whenever it hits that line, that's the breakpoint. That's where it stops. You can also set breakpoints differently than that, and give them a number. So if I were to run this, okay, so Python 2.7, what is this called? Pyaudio samples? Pyaudio samples. Voila. I even got a subplot on this one. Here's the raw time data. Here's the FFT. I'm feeling really good about myself. Okay? Super easy. Super easy. Rapid prototyping. Okay? That is what Python is built for. All right. Enough Python examples? Should we move on? All right, let's move on. You can also set up OpenCV and run it from Python. Okay? Very, very easy to do, and it's a really, really great wrapper. Okay? It allows you to get to C++ very quickly. Okay. If you do want to see more demos, they're littered all over the internet. You can also go to this website right here, which I found is if you've never done Python before and you want to see examples of a lot of the kind of bare bones code getting run, you can go in here to this Sandbox over at, I think this is Missouri. I can't remember. University of Missouri, maybe. But it's a really good introductory Python course. Okay? Yeah, they have a course on it. I don't know. All right, let's talk about Tornado. Tornado is something that we're going to run from Python. How many of you guys have set up a web server before? What'd you use? Apache, Amazon. Okay. Now I hear just mumble. Okay. How many concurrent requests could you handle? Huh? Many? What's many? If it's threaded, it's about 10,000. Good. That's good. Essentially, Tornado is something that was built it's a non-blocking web server, and it is built for short-lived requests. So it's imagining that you've got a bunch of people that are trying to request either with GET or POST data from you. You're your web server, and it's very short-lived requests that you can handle, spit the data back out, and keep running. Right? Keep handling the requests that are there. This was something that was very much built to scale in an attempt to solve the 10,000 concurrent problem, where you can handle 10,000 requests per second. Okay, concurrent requests on a single machine. Tornado has a Python implementation. Essentially, this was open sourced by Facebook when they acquired friendfeed.com. Right, all of this was written in something in Python for friendfeed.com. They open sourced this web server. You will have to do some load balancing if you want to run Tornado and handle 10,000 concurrent connections per second. And you would do that through Nginx. You guys use Nginx? Anybody? You have. Yeah. That's how you got 10,000 in the first place.
I read there's like a bunch of research articles on the C10K problem. We did it for a network.
Good. So if Tornado by itself will handle, if you just run Tornado without Nginx, it can handle about 3,500 concurrent connections per second. If you run it with Nginx, it's somewhere between 9,000 and 17,000. Okay, depending on how well you implement your code. Okay. It uses an I/O loop and a callback model as your web server. Okay, so if you want to install Tornado, you would do sudo port install. This is what I did. pi27-tornado. Okay, that installs everything for the framework. Okay, very quickly. If you're using pip, say you're on Windows, pip install Tornado, and you will get something that looks like the output of this, right? Where I did the sudo port install, it goes bam, and it's done. Okay, now you have a web server. Was yours that easy to set up? Not necessarily. Okay. I'm going to say that's a no then. Okay, so here's your Tornado I/O loop. So there's a couple of classes that you'll get access to by downloading Tornado. If you import Tornado, you've got their HTTP server, which essentially is running everything that you see there. That's their entire web server. Inside of this Tornado I/O loop, what you'll have is you have clients that want to connect. Tornado is running inside of this I/O loop, and it's going to try to serve as many clients as it can at one time. Okay? And the way that it does that is by polling. Right? So it's polling this I/O loop, right, using this tornado.ioloop.poll. And anytime that it gets a connection, what it's going to do is it's going to filter that connection through tornado.web.application. Okay, so this essentially handles all sockets. It will give you access to their HTTP connections, right? So if you wanted to create a new connection. And then based on this tornado.web application, this is where you would do things like have a model view controller if you wanted to do different routing through the application. And then every time that it connects or it detects a new connection, this event-triggered connection, it's going to create a new instance of a request handler, and it's going to send it off to wherever you tell it to request this, essentially whatever you want it to request from, this handler. Okay? That's probably not very clear, so let's go through these one by one. So your Tornado I/O loop, it's edge-triggered if possible, right? And what that means is that if you're running on Mac or Linux, this is going to be edge-triggered. Okay? And that means that every time that someone wants to connect to you, it's going to, this I/O loop is going to immediately say, hey, someone wants to connect, and that is the only notification that you get. All right? So it says, hey, someone wants to connect, and it handles it some way, and then it keeps going. It keeps polling as fast as it can. Okay? That's different than level triggered, which is say, hey, someone wants to connect. If you don't service that, hey, someone wants to connect. They're still trying to connect, right? That is something that is essentially kind of a level trigger design. So if you don't have the right libraries installed, or let's say you're running from Windows, it's going to default back to a level trigger design, okay, when you're running Tornado. It handles all of the callback registration that you have, right? So all of the callback functions that you want to handle different requests. And it handles all the new connections inside of this I/O loop, okay? Oh, and if you have a connection, it's connected, and they have some new data, it also will handle that inside of the I/O loop.poll. Okay, so after it's polled and it said, hey, someone wants to connect, it's going to go over here to this tornado.web application. And this is where it routes different URLs to different handlers, right? So this application is where all of the logic happens for Tornado. And each handler, you might have a bunch of different handlers for a lot of different requests, right? Each handler is going to be of type request handler. Okay, so every time you write a handler, you're going to inherit from tornado.web.requestHandler. Okay, so you'll write a class and it will inherit from that. So a very, very quick example. If you wanted to create a web server and you wanted it to have, this is straight from Tornado's documentation. Essentially what's going to happen here is you're going to say import tornado.io. Well, let's start at the bottom. Okay, so essentially I'm going to say if name equals main, right? Whenever you call Python on a script, it's going to look for the main. Okay, so if name equals main, then I want to do this down here. I'm going to say application.listen, and application is a tornado.web application. Okay, so I'm going to say listen on 8888. That's the port, right? And then start the I/O loop on that port. Now, what these two lines of code did with this setup is essentially, I set up this application with a tuple, okay? And this tuple essentially had a URL that I'm connecting to and a handler for that URL. So everyone that tries to connect to the default URL for my web server, right? I've just got a little / right here. That's going to get handled with this class called main handler. Okay? Right? If I wanted this to be, some other file structure that I could have as part of my URL path, I can have each of those with a different path and a different handler if I want. Okay? Or the same handler. Right? So I could say / example, right? And now I would enter your web service URL / example. That would have a different handler inside Tornado. So this main handler, I have it inherit from tornado.web.requestHandler, like we talked about. And what I'm going to do is I'm going to override their get function. Okay? So I'm going to say define get, and I'm going to say self.write hello mobile sensing learning and control world. Okay? This is hello world for Tornado in this class. So what did I just do? What is get? Yes. What's a get request? That is true. That is absolutely true. So anyone that does a get request, right, will have this handler. Okay?
If you use like a URL that you haven't created a handler for, do you have like does it fall through to your main handler, or
it will default to your main handler. You'll get a 404. So I overwrite any get request that happens, and then I'm going to say self.write. What self.write is going to do is exactly that. It's going to display text, right? If I were to look at this in a web browser, I would see hello MSLC world. Okay? So if I wanted to do that, what I could do is I will say, let's say that all that code that I just showed you, right back here, all of that was inside of the function tornado web server.py. I can run that from the terminal. And then how do I connect to my web server? I need a URL. Yes. No, they don't. So when you're doing it from this class, what you're going to do is you're going to want to host your web server, and then you're going to want to go into settings and say, wow, what's the URL that I get to my Mac Mini, right? Or your laptop, right? Whatever you want to run. And essentially, if you go in here to settings under sharing, it will tell you what your computer name is, and computers on your local network can access your computer at ericsmacbookpro.local. Okay? And that's how you'll connect to it with the class. So from the phone, as long as you guys are on the same network, you'll be able to connect to one another. Or you can set up your own network on the Mac Mini and connect to that network. And this is the URL that you'll go to. Okay? So now, if I go to ericsmacbookpro.local and then give it the port number, 8888, that's what I'll see. All right? What else is in there? Oh, I can also do localhost, right? If I'm just on a web browser. That's great for debugging, right? Just localhost it. If your phone is connected to it, bam, I can connect my phone to ericsmacbook.pro.local, ericsmacbookpro.local, and I get the same thing. Wonderful. Feeling really good about myself. Okay? I created a web server to give me text. All right? And if you were to just run this, you can probably handle a lot more than 10,000 concurrent connections at a time if all you're sending back is one line of text. Okay? But it's non-blocking. Okay. Get requests with arguments. Let's say you want to do some get requests. The first thing that I can do is I can define this class called getExampleHandler. All right? And that's going to inherit from tornado.web.requestHandler. Okay? And now I overwrite my get. How do I get, what are the query arguments inside of a get request? Anybody? It's a key value pair. Yes, right? So, and it's in the URL. It is in the URL itself, okay? It's not in the body, okay? It is in the URL. So when someone sends something up, if you want to get an argument, let's say that argument's name is arg. In this example, I would say arg equals self.getArgument. This, the default value is none, okay? And just set that to true. Essentially what this will do is it will go into that query and it will get any of those arguments. So if arg is none, self.write, there's no arg in query. Otherwise, spit back out the query argument that was set there. Okay? Set it on the screen. Right? So someone will send up a query to me and they'll get the exact query back. Wonderful. Yeah. One front end. So we already talked about this. Tornado can handle about 3,000 concurrent connections. With Nginx, if you use 4 instances of Tornado, what Nginx will do is it'll set up 4 different instances of Tornado on 4 different ports. And anytime someone comes up to your web server, it will just spawn a Tornado, an instance of Tornado, and send it to that instance. And it's going to load balance between them. So if this instance of Tornado is handling a lot of concurrent users, and maybe it's bogged down, it's going to start going and it's going to try and load balance so that all of the instances of Tornado are requesting and running about the same amount of users. Okay? Yeah. The one caveat here is as long as you don't block the thread, right? So if you're running, you can get 9,000 to 17,000 concurrent connections, but if you block the thread inside of your GET request, you're not going to serve that many concurrent clients. Okay? Why is this important? Why am I talking to you about concurrent clients? It's like, when is my when is your web server going to have to handle 10,000 people at a time? Hopefully a lot. Okay? If you're writing something that's worthwhile. Okay? Big data. All right? Essentially, what you're going to be doing, we'll talk about it. We'll talk about it. Okay, so don't block the thread. Here's a blocking example. Okay, so I'm going to import tornado.io loop and tornado.web, and then I'm going to import HTTP client. Now let's say I want to do a Flickr search. Okay, so here is a URL for actually going into the Flickr's API and getting the most recent photos that have been uploaded to Flickr, right? Getting the metadata for all of those photos, right? And it's got an API key on it right here, which is actually just a default API key for Flickr. So what I'm going to do is I'm going to make this class called search handler, and in my get request, I'm going to say self.write searching on Flickr, right? Because I'm about to go and search on Flickr using this URL. So I'm going to create an HTTP client, and the way that I do that is through tornado.httpclient.httpclient. I get an instance of that. And then I'm going to go and fetch from this URL. Okay? All right, so I use this URL, I go and fetch, and I'll get a response back. All right? And then I can write, hey, we got a response, and then I will write the response.body out. Okay? And I'll do a replace this with this. Right? Essentially this open hash mark, so that it actually displays everything that I got back from Flickr. Right? It's just going to display all of the different photos that I got back. Right? What's the problem with this? Is there more? Hold on. No.
It's gonna take a long time.
That means anytime that someone comes to my web server, they're initiating this GET request, right? The first thing I do is I write searching on Flickr, and then I go out. This right here, this is blocking code, right? While Tornado is sitting there waiting for this to finish, it is not serving any other clients, right? It's not running its I/O loop, right? So it would be great if I could say, hey, create a callback function, and then once this is completed, don't kill my GET connection. Keep that open while this is running. I'll be serving other clients, and then once this comes back, my callback is going to come up, and I'm going to display everything out. Okay? So now this is how I would modify my search handler to do that. Here's my get function. I'm going to say, okay, self.write searching on Flickr. I'm going to do HTTP client, and I'm going to set up this thing called async HTTP client, which I get from Tornado, right? Now my response, I'm going to say is equal to HTTP client.fetch, and I'm going to give it my Flickr search URL that I want it to go do, and then I'm going to say self.handle response, right? That is the callback function for when that completes that I want to get called. So if I were to define that handle response, I can say self.write, hey, and we got a response. So now, whenever I kick this off, it immediately, Tornado is servicing all of the other clients that might be coming in. And then I can write this out once that fetch completes. Yeah? Good? It's a non-blocking example. There is this little thing up here, which is a little bit new, at tornado.web.asynchronous. This is what's called a decorator in Python. And it's essentially kind of changes the behavior for the function that occurs right after it, right? So essentially what this does is it tells Tornado not to call the finish function, okay? That's why you see self.finish down here inside of my handle response, okay? So I'm finishing off the connection that I have, right, from my GET request, right? Otherwise, the second that it got to the end of GET, it would call self.finish right there, and it would close the connection with my GET request. I want that to remain open while this is still running, okay? All right, what are we doing? Why is this important? This is all in preparation for A6, okay? In A6, what we're going to be doing is we need an HTTP server that can accept any kind of data, okay? Save it into a database, learn a model from all of the data that's in my database, and then be able to mediate all of the different queries and training of that model through my web server. Okay, so the web server is going to handle all of the queries and essentially spawn off all of the training and saving into my database. So Tornado is going to be the architecture that we use for interpreting all the commands. This is all going to be user-centered, right? You're on your iPhone and maybe you're sending up some data. And you want to so you'll say, hey, save that to the database, right? And then once you get enough data, you're going to say, hey, okay, train a model on that database. So your server's going to do that. And then you might get some new data and you're going to say, okay, predict something from this data in your onside of your web server. Okay? Tornado is going to say, okay, I want to do a prediction. Here's the data, do a prediction, come back, and I'll spit it back out. Okay? So that's why we're looking at this. And that's why these are... Okay, so how would you build an application that does that? Good. So one of the ways that we're going to do that is by subclassing application. Let's just get it all on screen. Okay, so the first thing I'm going to do is I'm going to set up all of the imports that I have on my Tornado. So tornado.web, HTTP server, IO loop, and then I'm going to import these two things called from tornado.options, define and options. Okay. When I want to set up my Tornado class, what I'll do is I can call this function define, and I'll set up the default port, right? So I'll set it up on default port 8000. And inside of this function right here is where all of my custom classes, all of my definitions, all of my request handlers are going to be. Okay, so this is where I will handle all of the requirements that I get from my phone, right? Which is insert this into the database, train a new model, or get a prediction from that model, right? Inside of my main, what I'm going to do is I'm going to create an HTTP server, and I'm going to use this function called HTTP server, which I imported up here, and I'm going to give it an application, right? An application I will need to define in here, and it'll need to inherit from tornado.web.application. Then I'm going to set my server to listen and an IO listen. So a lot, very, very similar to the code that we saw before. Okay? Okay. So now what I need to define is what the application looks like. Right? So this is going to inherit from Tornado Web Application. And I'm going to define an initializer function. Right? So my init is going to look like this. I'm going to set up some handlers. Right? I'm going to say, okay, here's the default handler. Right? When someone just comes to my web server, I want to call the base handler. All right? That is a class that I need to write. Right? My base handler. Then, whenever they come to my web server and the URL, they go to the test. Then I want to do, maybe I want to do this. Right? So example handlers.test handler. Okay? And I can have more handlers and URL paths, as many as I want. Right? So maybe I wanted to do a post request. So those are going to be the handlers. Here's my settings. I'll set debug equal to true. Right? So that it will, essentially Tornado will start spitting out some examples on my console as connections happen. So when the 404 happens, that will spit out on my console. And then I'm going to say, I'm going to call the superclass, right? So this inherits from Tornado Web Application. So I'm going to call the initializer for that. And I'm going to say, here are the handlers, right there. And here are my settings. Voila. Okay? Then this is where I'd want to set up any databases where I'm going to save the data from. And I can also define this exit function, which will happen whenever someone hits Control-C on the console, right? Whenever I get rid of this class. Self.client.close, that actually has to do with the database. I shouldn't have left that in there. Okay, base handler. I wrote this for you. Okay, wonderful. That's going to be great, right? What does that mean? Any handlers that you write right here, so any handlers that you write, they should inherit from base handler. Okay? That's going to make sure that nothing bad happens, right? Anything that happens, base handler is probably going to return a 404, but that's okay. We'll get to setting up the database in a moment. Okay. Get versus post. Somebody tell me the difference between a GET request and a POST request.
The post, you use it for sensitive data that you don't want to be displayed in the URL.
That's true.
And it's in the content of the HTTP.
It's in the body of your HTTP, right? It's not in the URL. What else?
Doesn't post, don't you like mess with things usually when you post?
Yeah, I mean, usually if you're uploading something, you'll do a POST request. Most of the time. Almost always. Right? Yeah. A GET request is usually when you're requesting something from a server, right? You're requesting some data. That's not to say that you wouldn't do, you can still request data with a POST request, because it depends on what you're trying to send up. Okay? With a POST request, there are really no restrictions. You can send up binary data with a POST request. Let's say it's inside of a file with a POST request. On a GET request, since it's part of the URL, you've got a maximum URL length of 2048 characters. Okay, and so you'll essentially be sending up data, and it all has to be ASCII characters, right? So this is where like you get like a base 64 encoding. And like you said before, it's less secure, right? Like if you have data and you want it to be as secure as possible, you're going to use POST requests, because the GET requests are saved in the browser and everybody can see it. All right? All right, good. So now that we know GET versus POST, let me show you what the base handler does. So let's look at what this base handler does that I wrote for you, and we'll actually get into running some Python code here. I built this for analyzing and writing back JSON encoded data. Okay? So what is JSON? It's a serialization format, right? Who has not used JSON before? Cool. This base handler is going to implement both GET and POST requests. And essentially, if you want to use it, you can say from base handler import base handler. Okay? Pretty cool. And then I can also do some import example handlers, right? So let's look at what this looks like in actual. All right. Is it over here? Let me check. Okay, so here's this running from Sublime Text here. Here's all of the code that we talked about just a little while ago, where I have my imports for Tornado. I have a main function here, which is essentially calling HTTP server, and it's pointing it towards this application class. Seriously? Towards this application class right here, which is something. So I set this up so that when you just go to the default web server, you get the base handler. If you go to test, you will get the example handler.test handler. Okay? And that is imported from this file called example handlers. All right? And so test handler, post handler, and then a file upload handler. Excellent. Wonderful. So let me go up here to example or to the base handler, and we'll show you what's in there. So essentially, there's a lot of different things inside of this base handler, so that you can get a JSON string, so that you can encode some custom JSON. So the base handler class, surprise, surprise, it comes from the request handler. And the GET request, the default thing that it does is raise an HTTP error, 404. Okay? It assumes that you're going to write, that if you try and do a GET request, that is something that you've written for your handler. Okay? If you haven't, you forget to do it, you're going to get a 404, and you'll be like, oh yeah, I need to write a handler for a GET. I have this convenience method called getIntArgument, right? So you essentially give it the argument name that you want and the default value for that, and it will return it as an integer. Get long argument, get float argument, and also write JSON. Okay? This will essentially be, you will give it a dictionary that you want it to write back out, and it will take that dictionary, it will convert it over to JSON, and it will send it back to your client. Okay? So, let's see. Let's just run it. So, this is under tornado example. So, I'm going to run tornado example.py, and we'll see what happens with my base handler. Okay, so Python 2.7. Wait, am I in the right ls? Yes, I am. Okay. So we will say Python 2.7 tornado example.py. So now I'm running. I've got a web server. Okay? So if I were to go over to here, I could, oh, I've already got it. Localhost. We'll go localhost 8888. You are not connected to the internet. That's wonderful.
And the port is wrong.
Is it? Let me see.
You say it was 8.
Look at that. It is. Ah, ooh,
Without that comma.
wow. 404, not found. Okay? That was my base handler. Okay? What else did I have inside of here? Well, there's a test. With my test handler, what does that do? Example handler, test handler. It inherits from base handler. I've overwritten the get. So this will be test of hello world. All right, let's see what that does. Oh my goodness. Wonderful. Post handler. Oh goodness. So if I go to the post handler, if it's a post request, what I'm going to get back is it's going to say arg1. It's going to go in and it's going to get a float argument, default value of 1.0, and then it's going to write back this JSON, which is the argument that I sent up, and then 4 times that argument that I sent up. Okay, just an example of how you would write back JSON. Right? This right here, curly braces. What does that mean for Python? It's a dictionary. Yeah, right? So I send in a dictionary and it JSONifies it for me. Okay? Right? I also wrote a GET request for this. Right? So if I do a GET request, arg1 is going to be equal to, this is a GET from post handler, and then it's going to get a string of my argument times 2. All right? So if I go over here to do post, that in get from post handler, none. Nothing there. Okay? How would I add a query to this? arg1 equals 3. You guys even see that up there? Yeah, okay. You guys got good eyes. Oh, look at that. 2 times 3 is 6. Okay? So now my web server is handling data that I'm sending up to it via GET requests. Okay? I can also put a post request together. I'm not going to do that from a browser. Okay? Okay, good. And let's see what spit out. Hey, look at that. I've got some things that are spitting stuff out, right? This is because debug is on. Okay? Good. Okay. Control C is what I just did there. All right. Okay. So, what you're going to be doing, if we're sending data to a server, right, for processing, that is of unknown length. It might have a lot of different formats, and possibly we're going to send it in a multi-part file. Oh, by the way, I gave an example of an upload file handler in there. That's not going to run without Nginx running on the front end, okay, for Tornado. Anyway, back to this. So if you're going to be sending up data to this server, our web server, are you going to do it via GET request or POST? POST. How did you know that you were going to do a POST request?
Get receives post sends.
Post sends, right? The second that I said sending data, that's when you knew it was post request. All right, all of that other stuff was just filler. Okay. You're sending data, it's going to be a post request. Okay. If you're getting data, it's probably going to be a GET request. Okay. It depends on how you're querying. If you need to send up data and it's binary, you're not going to do it through a GET request, are you? Unless you make it base 64 and convert it over. You might do it with a post request. Okay? It's a little more versatile that way. Okay. So essentially we had already seen this. This is identical to the handling of a GET request. In our implementation, I was returning JSON. So this post handler looked like this. All right, so the post request, bam, there you go. And it sends us back as JSON. Okay, you could also, I could also write this out as, right, like in my example handler, I could say self.write this inside the GET request, right? I could do this, save, get float argument, and write it out as JSON. What would that look like? Well, if I did that, it's going to look like that. Okay, arg1 equals 3, arg2 equals 12, 4 times, right? So this is what you will get back with your JSON. Okay, so those are the tornado examples. Note that it's okay to block very, very quickly when you're doing a database query. That's considered okay. If you're doing a query on your database and it's a very, very quick query, that's something that you should not essentially set up a callback for. There's more overhead in setting up that callback than there is in just querying the database and sending it back down. Okay, so it's considered okay to block on very quick queries. Okay? So what database are we going to use? MongoDB. Are there any other questions on Tornado? No? Pretty simple.
At the beginning, you said that it was for like short-term requests. Their documentation says it's for long polling requests.
It's for long polling requests? No, you're right. It's optimized for pipelined request, right? So even though you may have a long concurrent connection, it's optimized for things that are going to be essentially non-blocking. That makes sense? So if you were going to do something that was going to block, you probably want to spawn it off in a separate thread, return back to Tornado, and then have the callback come whenever that ends, right? And you can do that through Python's multi-core processing, multiprocessing, if you want to. No. You can, and there's not any gotchas that are associated with that. It's just you're taking up more threads that Tornado could be using. And so it's better to use Nginx as a load balancer and not really worry about too much, right? So if you've got a lot of things that you know are data-intensive tasks, what you might do is actually have a separate URL that Nginx forwards those onto. So here's the instance of Tornado that is going to be handling these really data-intensive tasks, and you will always spawn those off, right? Because you know that you're only going to be able to do, say, 1,000 concurrent tasks on that thread, and you'll always send them to that version of Tornado, while this is handling all of the quick things that you know are going to happen. Okay?
You said that when you use Tornado to make your computer a server, you can connect to it, like anyone who's connected to the same Wi-Fi network can access your computer as a server.
Mm-hmm.
Is there any way to use Tornado to make your computer a real world server that you can access?
It is.
on web?
It is a real world web server. It's just like, is your IP, visible to the world, right? That's something you have to set up on your network, right? Yeah. SMU is not about that. SMU is not going to do that for you. Essentially, you will have to request to them, like, someone to forward all of the data traffic that happens on this URL in the PerunaNet network. They're going to forward that on to your URL so you can handle all those web server requests. You would have to set that up.
We don't
And
have NAT. PerunaNet doesn't use NAT, so we don't have a fully external IP.
are you serious?
Yeah.
Oh, so you can.
It's one of the things like our network engineers don't want to set up NAT because it messes with how people use web servers.
Perfect. So you can do that. All right? Don't abuse that. So next class period, we'll be using iOS to send post and get requests to our web server. But before we can do that, we really need a database so our web server does something more than just hello world. Okay? So let's do it. MongoDB, how much time do we have? 36. 20 minutes? 14 minutes. 15 minutes. Call it 14 because it is 14. All right. MongoDB. Mongo stands for humongous data. Mongo. Okay? MongoDB is a NoSQL database, right? What is NoSQL? Somebody tell me. What's a relational database?
Where you have information based on build a table. The table only contains values that have a value for each.
No, that's fine. You're setting up a schema, right? You set up a data schema, right? And that schema consists of, here's the tables. Inside of my table, I'm going to have an int. I'm going to have a blob. I'm going to have whatever. I'm going to have some strings. I'm going to have a date stamp. You know what your schema is when you're setting up your database, right? So I've got some users. I'm going to want a username. I'm going to want passwords. I'm going to want height and weight, whatever your database is. But you know that beforehand. Okay? What's the problem with that? Yeah, if all of a sudden you want to change your schema, like you're creating a database and you want to save some things in it, if you change your schema, your entire database has to be ported over, changing the schema, and then all of that data re-entered. Okay? That's not great for when you have a database that you want to scale very, very quickly and you don't know exactly what data you want to have from your users, right? So there's this thing called NoSQL databases, which do not have a predefined schema, right? MongoDB has something that uses, this is called a document database. So this is a type of NoSQL database that uses documents, okay? Everything is stored as a document, which more or less means that it is a JSON object inside of the database, okay? Which means that you have a key and you have a value, or you have a key in an array that it has access to. That is considered a document, okay? And the schema is dynamic, and that is the key advantage of MongoDB. If you look at the resources that you need for keeping a relational database when you get a lot of different users, essentially you don't scale very well when you have a relational database because you keep having to update your entire database with these new relations that you want to save of your users. With MongoDB, if you were using that, you just start saving it, right? And if you get new data, that gets saved inside the document. You don't have to have a schema set up beforehand. I don't have to know that I'm going to need username and password and then height and weight, and then somewhere down the line I figure out that I also need a Twitter handle, right? I don't have to save Twitter handle for everybody else on our database. I just add it in, and it automatically saves for the people that provide their Twitter handle, okay? So if you want to install MongoDB, you go to mongodb.org downloads, and then you download it. Okay? When you want to run it, you need to make a directory for where all of the data is going to be stored inside of your database. So if you're running a single server database, what I mean by that is your computer has all of the data. One computer looking at the database, right? You could also have multiple computers that are all looking at the same database. Okay? That's completely fine. And you'll see that a lot with the big data. So if my database path was right here, I would say MongoD, DB path, bam, and I am running now. Okay, I would be running localhost, default parameters. No, look at that. Okay, so a document as stated by MongoDB, this is straight off of their website. Here is a document right here, right? I have Sue, she's 26, she has an A, and she's as part of groups, news, and sports, okay? If I get, essentially when I save this in, it's gonna be a JSON object. A JSON object, anyway, JSON. So if I get someone ever new right here and their name is Brian, and he has, I don't know, a new field value. Let's say that field was, instead of groups, he also had like clubs that he belonged to. I can immediately save that without changing my schema. Okay? That's the advantage of MongoDB. Okay, so there's a Python wrapper for MongoDB. I'm thinking whether or not I should launch into MongoDB right now, because there's a lot and we're never going to cover it all. All right. I'm going to say that we'll get into it next time. Next time what we'll do is we'll go into MongoDB, because I'm going to have to go over all of this next time anyway as we go into it. We'll go into MongoDB, and then we'll go into iOS and how to go up and look at the HTTP, handling HTTP requests and post requests. Okay? Before then, look at MongoDB on the internets. Okay, just get an idea of what it is. Okay, it is the leading NoSQL database out there. Okay, that means if you get a job and you're using NoSQL databases, chances are you're going to use MongoDB. Does Twitter use MongoDB?
They use NoSQL.
I don't know. It's number one, so I wouldn't be surprised if Twitter did use it. Okay. All right. We're done. Finish.